Welcome to my series. In this series I will be guiding you through the process of making a Pokemon-style game. It is all unscripted and unplanned, so you will see me go back and change a lot of code. This is an intermediate level series. You should know basic scripting to follow along. I will also be using luau types. I am adding a script in server script service. The first thing I am making is the battle system. This script will handle the server side of battling. I decided to call my Pokemon bobbies. I will be adding the bobbies module script later. Now I am making my first bobby. It is very boring, so I will speed it up. Now I am making the script to store information about bobbies in replicated storage. The get function will return information about a bobby. I am adding type annotations, which are the colons with the types after the parameter and function. I am making a type called bobby, which will be the basic format for each bobby. Types in luau are only used when you are writing code. They will not appear when the code runs, but provide structure for your game. They are useful for catching errors, documentation, and autocomplete. I will link an article in the description if you want to learn more about them. This get function is temporary. Later on, I can improve it with a more robust way to add bobbies, but for now I want to get the battle system up and running as fast as possible, so I am using a basic if statement. Also, I forgot to say, but the bobby I made earlier was called ready. Here, I'm just filling out the information about ready using the bobby type. Now I am making another bobby called Bluey, who will be the enemy. I set the primary part on both of my bobbies so it will be easier to work with them later. I am also naming the parts so it's more organized. I also want the front of the main body part to be the front of the bobby. You can right-click on a part, then click Show Orientation Indicator to see where its front is. I am doing this, then rotating the main body part so it faces the front of the bobby. Now I am going to make a folder in replicated storage called Bobby Models and put my Bobby models in there. My bobbies are finished, so I can work on the battle system now. The first thing I do is make variables for the things I will be using. I am now making a part which the player will touch to start the battle. Now I am making a folder in replicated storage which will contain remote events and functions I need. Now in my server script, I am adding the functionality to start the battle when you touch the part. This is only temporary, but will get the battle system running quickly. When you touch the part, it's going to fire an event to the client telling it the battle has begun. Then the client will render the battle and everything necessary for the battle. The server will send basic information about the battle to the client. The idea here is to keep all the battle logic on the server and all the visuals on the client. This makes things more secure and also keeps things smooth on the client. A table is passed to the client when the remote is fired. Them is the player's bobby. Opponent is the enemy bobby. With the server part down, I am now moving on to the client part. I make a script in starter player scripts called Client Battle. I also rename my server script from Combat to Battle. I also rename my Bobbies module script to Bobby Stats because it's more specific. As always, I start off my script by listing the things I will be using. For better autocomplete, I am making a module script called Remote Types which will contain types that I use in my remote events and functions. When you put export before a type, it lets other scripts use that type when they require the module. Here, I use the double colons to cast to my battle info type. This is to make sure that the table fits the type. I also add strict to the top. Strict will create an error if the types don't match. Now, I'm back in my client battle script and I make it strict as well. With all the typing done, I can focus on implementing the battle. I am going to make the platforms for my bobbies to stand on like in this image. I make two parts, make sure they face each other, then group them into a model called Battleground. I will clone my bobby models then place them on the platforms using Pivot to. I also have to make sure the pivots of the bobbies are on the bottom, so when I use Pivot to, they don't appear in the middle of the platforms. Now to test it. Looks like I messed something up. If you look at the output, you can see I pivoted to the part instead of the C-frame where the part is. Luckily, the fix for this is easy. It works. Now I am going to make the UI. I am testing to see if it works on other devices. You can do this by opening the emulator in the test menu at the top. I can see that it's a little too big for some phones. My solution is to add a UI scale. Later, I will scale the element with a script, but for now, I want to focus on the battle system. Here, I am just renaming some things. Then I make some more changes to the UI. It's ugly right now, but my main focus is the battle system. Once I get that working, I can focus on making things look nice. Once the UI is done, I put it in replicated storage. The first step to get the UI working is to make it visible. I do this by placing it in the player's player GUI. Now I test it. Oh no, it errored. Looks like I forgot something while I was renaming things. Now it works. To get the UI displaying actual health, we have to define the state of the battle. The state of the battle is all the information about the battle including the health of our bobbies. I make a new module script called battle state that will contain the battle state type and other utilities for the battle. I am trying to think of what the state should contain. Once I add things like a party system, it will probably end up looking very different. I don't want to think about that right now, so I go with what's simplest. Also, I'm going back to add a health stat to my bobbies which I forgot. Now, back in my main client script, I define the state using the type I made. I am now making a function which will update the UI based on the state. If you're wondering what the type of syntax is, it gets the type of any expression. Here, I am getting the type of the battle UI. This will give me autocomplete for it, which is nice. I decide to put the stats in the battle state so I don't have to look it up again every update. I might remove this later since the stats should be independent of the battle state. Here, I am organizing my types a little more. Back to my UI. I am putting the stats directly in the Bobby stats table because it's already called stats. Now I am making my UI code, which is just a basic name and health bar. Now to test it. It worked, but the name of the opponent is wrong. Testing it again. The name is still wrong. Now it should work. To test two things at once, I am also writing a test to see if the health bar works. It worked. Since I don't need it anymore, I remove the test. Now we will add attacking. To do this, we need to make the UI for it. I make a frame called options that will contain buttons for attacking, switching bobbies, and looking in your inventory, and another frame called attacks that will contain the attacks. It will be ugly, but we will fix it up later. Now I will make it so when you click attack it will show you the attacks. Testing it. I forgot to make the options frame visible at the start. Now the buttons work. Now I will make the smack work. I first made sure the button was clickable. I don't know why I had to test this. I will speed it up since it is very basic. Also, I decided to make blue your Bobby instead of ready because it was confusing that the colors were swapped with the UI. Now I am making the message pop up like in this image. The code to display the message will just set the text and make it visible then invisible after a few seconds. Now I'm going to test if the message pop-up works by displaying a message when you click the smack button. It worked. Now for the actual smacking code, I will fire a remote event to the server telling it that the player used smack. I add a debounce so the player can't spam the server. I set up the basic remote event for attacking. And then I add a variable called turn to the state that will track whose turn it is. Now I am making the server handle the attack event, but then I realize a problem: the server doesn't keep track of the state. I solve this by creating a variable called active battles that contains the state for each player's battle. I also extract the code for starting a battle into its own function. Keeping track of data is a common problem in programming. In other parts of this series we will come across problems like this again. This is the benefit of a type system, which helps us keep track of what data is what, so we can more confidently handle more complex state as we add more features. Now I am changing it so that instead of the client creating the state, it will receive it from the server, which will create it when the battle starts. I do this by copying and pasting the client state code into the server, making a few adjustments, and changing the parameters for the start battle remote event. Also, you can see I mess up and accidentally connect the start battle function to the attack remote event. Since that was a lot of changes, I have to test it. I made an error. Here you will see me trying to figure it out. I can't figure it out, so I resort to printing out the state. This is a drawback with putting all our state in the code. It is harder to access. You can see that we are missing the turn, opponent Bobby, and your Bobby keys. At this point I realize the mistake I made. It was a very silly one. I connected the start battle function to the attack remote event instead of the part touched event. Now I test. It works. The only error is that it says I am already in a battle. That is because the touched event fires multiple times. I fix this by making sure I am not already in a battle before calling the start battle function. I also make sure to delete any battle state after a player leaves so there isn't a memory leak. Here I am thinking. I am speeding up this section since nothing happens. Now I finally get back to my attack remote event after all that refactoring. The first thing I do is access the state. Then I make sure it's your turn. I start simple, subtracting from the enemy Bobby's health when smack is used. We have the state changed on the server, so now we have to tell the client the state changed. There are many ways you can send state changes, like by sending the entire state again, or telling the client what happened so they can calculate the changes on their own. The solution I choose is to send a diff, which is a table with all the things that changed. Then the client can go through the diff and paste in the values without having to worry about doing any calculations. This is better than sending the entire state because it saves on bandwidth, especially as we add more things to the state. It is also better than making the client calculate it because that requires more code, which means more things to keep track of. The main drawback is that we now have to manually keep track of changes to send to the client. If we forget something, the client will go out of sync. It is possible to do it automatically, but I think that is too large of a detour to take for this series. As always, we have to make trade-offs. Also, the second parameter that I am writing right now is the message that will display when the client receives the event. Now I will work on the client side and how it handles receiving the attack event. Here you can see me using any. Any is a special type that lets you escape the type system. I am using it here for convenience because the type system is not always great to work with. Now you can see that I made a function called update with diff. All it does is applies a diff onto a table. Remember that a diff is just a table with only the changed keys, so it is basically pasting all the changed keys from the server state onto the client state, which is the same as syncing it up with the server. This is a diagram I made of what is happening. We can implement this function by going through every key in the diff and replacing the corresponding key of the main table. However, if we try to replace a table inside the diff, we may lose some keys since the diff only keeps track of changed keys. The solution is to use recursion and treat each table within the diff as its own diff. Since the state changed, we also have to update the UI so it displays the most recent information. Also, I forgot, so I go back and make sure to change to the opponent's turn after you attack. Then I decide to make a new remote event called update state, which will be separate from attack. This event will be fired whenever the server has to sync up with the client. Later on, I will add the attack remote event back. If this is getting convoluted, here is a diagram I made of what will happen during an attack.
Client. Hey, I attacked and used smack.
Server. Okay. Here are the changes I made after you use smack. Also, make sure to display this message.
Client. Okay. Now I will update my state with the appropriate changes from the diff and display the message you provided.
Back to our code, we will now implement this as well as enemy attacks. Here, I'm just jumping around while I figure out what to do. Then I decide that the first thing to do is make sure the player can't do anything when it is the enemy's turn. This is done by disabling the options and attack UI. I do this by setting the frames for the player's controls to false if it is not their turn. Now I am making the enemy attack by having it subtract the health of the player's Bobby by its damage. I also go back and make the player's Bobby's damage equal to its attack instead of just being 5. At this point, I decide to extract the attack logic into its own function. This is so that I can just call the function for the player and enemy instead of having to copy and paste it. This will also help when we expand the attack system. Here, I realize that the server can also use a diff to update its state. Then it can just send that diff to the client. That way, it will be harder to make mistakes because if we forget to add something to the diff, it won't work on either the server or the client. So, I move all my changes into a diff. After I finish extracting the attack function, I call it again so the enemy can attack the player. Now I test and hope it works. I forgot to add back the attack remote event. Another error. The reason this happened is because my diff does not have a key called yourBobby. I fixed this by adding the yourBobby key manually. Testing it again. Another bug. It looks like the server state updated, but the client's did not. It looks like I forgot to fire the update state event. Now let's see if it works. It worked, but the enemy's health did not change at first. I can't find the bug, so I print the diff to get a better picture. Nothing looks wrong, which is strange. Here, you can see I am now grouping the attack and options frames together into a frame called Your Turn. The Your Turn frame will only be visible on the player's turn and will contain all their actions. This lets me easily restore them to their original visibility after setting them invisible when it's not the player's turn. After that brief change, I returned to the original problem of the health not updating with some more print debugging. I forgot to make the attack and option frames visible. It takes me a while to figure it out, so I'm speeding this up. Testing again. It still doesn't seem to be updating on the first turn for some reason. The reason it wasn't updating was because the UI updated after the message finished displaying. The solution is to make sure the UI updates first. Now it works. The last part is to add winning and losing. I do this by making a function called tryEnd in my server script. TryEnd will attempt to end the battle if any of the bobbies are dead, and will return true if the battle ended. It will fire a remote event to the client if this happens. If the battle was successfully ended, I will end the attack event early using return. Now I am adding the logic on the client to respond to the battle ending. Now to test it. Woohoo! It worked! The last change I make is to clean up once the battle ends so you can battle again. It's finished!